Okay, so section 8.2, arithmetic sequences and partial sums, or you call them arithmetic, tomato, tomato, I don't really care. But what is an arithmetic sequence? It's a sequence that has a common difference. So an example, 1, 4, 7, 10. What's the pattern? You're adding 3. It could also be subtracting the same number as well. The bottom line is that consecutive terms have the same difference, right? So in this case, A2 minus A1 equals A3 minus A2 equals A4 minus A3 and so forth. These called the common difference. A1, A2, A3, A sub n are the terms in the arithmetic sequence. So for example 1, that should be very, very straightforward. All you're going to do is just write the first 3 terms. So here we go. A1, A2, A3. What's A1 here? 7. And then you're just adding 3, right? Sorry, you're adding 4. You're adding 4. So you get 11 and then 15. Very simple, right? A1 here is 2, negative 3, and then negative 8. Let's say A1, A2, and A3. So the nth term, A1 plus D, or A2 is A1 plus D, A3 is A1 plus 2D plus 3D, and so forth. So ultimately, it looks like, what pattern do you notice here? AN equals A1 plus what? N minus 1. Yeah, because what you're doing, and the reason why it's N minus 1 is that if you want to find the, let's say, the 10th term, if you have the first term, how many more times do I need to apply the common difference to get from the first term to the 10th term? 9 times, right? Well, what about the 100th term? I have to apply the common difference 99 times. That's why it's N minus 1. You see that pattern. But yeah, if you think like that, like the number of times I have to apply the common difference after the first term, then it's not really a memorization thing. You just know it, right? So the nth term of this arithmetic sequence will be A1 plus N minus 1 times D, where D is a common difference and A1 is the first term. That's always going to be true. And no, I will not give you this formula. You need to know it. So AN equals A1 plus N minus 1 times D. But again, just think of it as a first term plus number of times the common difference has to be applied. So let's look at example 2. Find the form for the nth term of an infinite arithmetic sequence. The common difference is 3 and its first term is 2. Okay. So the first term is 2. N minus 1 times 3. And that's it. If you want to clean it up, you could clean it up just a tad. It would be 3n minus 1. So this will find any term you want in the sequence, right? So in the first 3 terms, first 3 terms would be 2, and then you're adding 3, 5, and 8. So there you go. Does that make sense? What I just did? We're good? Okay. Yeah, in the first set of instructions, right, find a form for the nth term of the infinite. I mean, I'm not sure how it's any different than find the nth term, but anyway. For example 3, the fourth term is 20, the third term is 65. Write the first 13 terms of the sequence. Okay. Well, here's the deal. Okay. To get from 20 to 65. To get from 20 to 65, what's the difference between these two numbers? 45. How many times I have to apply the common difference to get from A4 to A13? 9 times, because if you have A4, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So I gotta do it 9 times. So instead of like getting too formula intensive, just think like this: 65 minus 20 divided by 9. That's gonna be your common difference. What's 45 divided by 9? 5, perfect. So all you're doing is just adding 5. So that's 15, 10, and 5. And if you want to write the rest of them, I mean, it gets to be very cumbersome to do it this way. Yeah, there you go. But that's just an efficient way of doing it. Some people will like, well, I got to plug into the formula. Like I got to plug in A4 and solve for A1. I mean, some people really kind of don't think critically about this. Like, again, this is what you should do. What you should not do, don't do this. What you should not do, and I'm recording good. Some students will say, well, A4 equals A1 plus n minus 1 times D. So they'll say, oh, 20 equals A1 plus 4 minus 1. And then they'll do this. And then they'll do like, some sort of substitution, like system equation. You could do all that work, but seriously, just think about how many times you're applying the common difference from one term to the other. That's just more effective, right? Or more efficient. So anyway, here. Find the 20th term of the arithmetic sequence. The first two terms are 2 and 9. What's your common difference? Common difference, guys? And what's your first term? So now we know what to do. 2 plus 19 times 7. Because you have to apply the common difference 19 times after the first term. 19 times 7, that's 153, I think. 133, my bad. Wow, I'm off. Boom, 135. Negative? What? What's you talking about? I don't know. You must be ahead of me. I don't know. Okay, let's keep moving, guys. Was anyone still copying? I'm sorry. Are you guys okay? All right. Example 5. A1 is 3. A sub k plus 1 equals A sub k minus 2. Write the first 5 terms, then find the common difference, write the nth term. Okay. So this is a recursive sequence, just so you know. So what we've done so far, this right here, I should have said this earlier. That's called an explicit formula. When you think of explicit, you think like being very direct. Like in hip-hop music, there's explicit lyrics, right? It's very direct, kind of the same thing. This gets you to the term you want directly. It's actually more advantageous to use that formula if you can. This one's obviously recursive, but it's going to follow an arithmetic pattern because we're dealing with arithmetic sequences, right? But this right here is recursive. So for example, in k is 1, you have A2 equals A1 minus 2. You get 1, right? Next up, A3 equals A2 minus 2. That's going to be 1 minus 2 or negative 1. What's the pattern you're noticing, guys? Subtract by 2 and duh, you'd have minus 2, right? So you know what? This is stupid. Let's just do this. Why even waste our time? There you go. This is my first 5 terms. Common difference is negative 2. The nth term is 3 plus n minus 1 times negative 2. And you can leave it like that. That's totally fine. If you want to simplify it, go ahead. Negative 2n plus 5, I think. If you simplify it, so there you go. Either way is fine. So I think the key takeaway here, don't get too caught in the recursive situation. If you see a pattern, cool. Go for it, right? You're done. Go for it. All right. The sum. Ooh, this is my favorite. I love this. This is really, really cool. Okay. I've got a good little activity I'm going to do with you guys. I wish I actually printed this, but it's okay. It's okay. I'll just project it. This is actually probably my favorite lesson I've ever made in my 20 years of teaching. I kid you not. I love this. Here we go. Actually, I teach this people who don't know math and they love it. Okay, here we go. This is I was doing it for a poker tournament, but let's just ignore that part. Here. I combined this with like probability, but anyway, let's look at this here. All right. So a little hard to read, so I'll read for you guys. So this is our auditorium follows an arithmetic sequence with the rows. You guys are going to be in there a lot in 2 weeks. Yeah, spirit with right. It's gonna be fun. Great. So anyway, let's assume the seats follow that pattern. So like, we'll say the first row 16 seats. Okay, just throwing out. I don't know. I didn't test it, but and let's say each row. I mean, I know each row does get wider, but what pattern? I don't know if there's a pattern, but let's assume it goes up by 2, and our total 20 rows. Okay. So the question is, let's determine the number of seats in R20. So there's a few ways you could do it. One way you could do it is you could just add them up by brute force. Like, okay, well, I got 16 plus 18 plus ... You know, until you get to the end, right? You could do that, but that's a pain in the ass. We don't want to do it that way. So let's think of it a little differently. Let's think of it like this. The first term is 16, right? The next term is 18. What do you think the 20th term would be? Remember, 16 is the first term, you're adding 2. So how many times do I have to apply the complement of 2 to get 19 plus 2? 19 times 2 plus 16, right. Well, that's like the pattern. So what's that going to be? 54. Okay, good. So now here's what we notice. 16, 18. What's the second to last row going to have? And the last row, 54, right? Now, what do you notice here? So what's going to happen is that as you whittle your way to the middle, every pair is going to have what? 70, right? 64, 70, 82, 70, 20, and 50, 70, and so forth, right? And how many pairs do I have? The 10 pairs. So 10 times 16 plus 54. That's pretty efficient. People who are very phobic with math, like seriously art teachers and stuff, when I did this little activity with them, because we had like a professional development day of how to make math relatable, like, oh my God, this is so cool. You were my math teacher many years ago. I don't know, but I'm too young back then. But anyway, it's 700. No, I know it's not truly 700, but that's an efficient way, right? Now, is there a formula we can devise based on what I just showed you guys? Is there a formula I could devise here? Go ahead, Captain. Go ahead. Yes. 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 You're awesome. Good. There you go. First term is A1. And the last term, nth term. And I multiplied by 10, right? Remember I took 16 and 54, the number of rows the number of seats in the first row, the number of seats in the last row. And then I know I have 20 rows, but if I divide that by 2, I have 10 pairs. If you take the number of rows, divide by 2, multiply that is the formula. That's how it's devised. So A1, some people write it like this. Some people write like that also. Now, when I've taught this to like, at level 3 calculus, at level 2 sometimes. And it looks cryptic, they get scared, like, oh, I'm gonna memorize it. You guys are way better than that. You guys can understand it. So I'm not gonna get into this and force you to know it. Just think about it. First term plus last term. If you go like this, actually that might be easier, right? Because you're taking the number of rows or number of terms, divide by 2, and that's what you're got. You know they're all gonna pair up into a consistent sum. And S sub n is the notation we use for the sum of the terms, right? So, and any juniors doing SAT or ACT coming up soon? Sometimes they ask this question. You don't have the formula. Sometimes I've seen on the ACT actually a question like this, very similar. So it's good if you know what's going on instead of adding by brute force, which takes too long. All right. So now let's come back to this. Now you know the formula, right? I didn't want to just tell it to you guys. I want you to understand. Now you understand. Okay, and so why? Because guys, quiet, please. Okay, that's it, guys. Guys, quiet. Why does this work? Because A1 and A sub n, A2 and A sub n minus 1, and so on, add to a consistent sum, and we have n over 2 pairs. That's the reason why. Now, if you want to find the 149th partial sum, well, let's find the 148th term first. What's 148th term going to be? -1 plus how many? What's the common difference here? So I'll do this. Well, I need to pair them up first because 149 is an odd number, right? Don't worry, we'll get the 149th term for sure, and not a problem. But actually, you know what? I'm losing my mind. Yes, you're right, UV. I was still in the exploration activity mode. Sorry. Yeah, let's find the 149th term. I'm stupid. I don't know what I'm thinking. Let's 149th term. Yeah, sorry. You're right, UV. I will give you a calculator, by the way. Because I think it's fair. Maybe a 4-function calculator. -1 plus 148 times 3. You get 443. 443. So guys, quiet, please. So if you do that, you should get this. There you go. Right? 32,929. So pretty easy. Makes sense, right? Okay. Now here, a few ways you could do this. One way is you could find the first term and the last term, right? That's easy. The first term is 5. The 100th term is 302, right? The common difference is 3 because that's a coefficient next to n, right? So for example, if you plug in 2, you should get 8. Plug in 3, you should get 11. Plug in 4, you should get 14. You're adding 3 over and over again, right? So 5 plus 302. Actually, I don't know why I even did D. That wasn't even necessary. That's just to prove it's an arithmetic sequence. Or actually, sorry, we call this a series now. When you're adding up, you call them series. When you're listing, it's a sequence. So let me actually make sure you guys are clear on that. Sequence, just a list of terms. Series, sum of terms. Yeah, don't mix up those terms. Don't mix up those words. Sequence just lists terms. Series of sum of terms. So we're fine. So what I did here, why I found what D was, just to make sure it's an arithmetic series, right? But I didn't need it for the formula. 100 terms divided by 2. 307 times 50. You should get 15,350. Here you go. Make sense? Yep. Yep. We're okay. Okay, last problem. And you guys can start homework. And I'll probably turn the homework again. A business sells 20 grand worth of sports memorabilia in its first year. The other business has the goal of increasing sales by $15,000 each year for the next 19 years. Okay. Or for for the next 19 years. So assuming that this goal is met, find the total sales for the first 20 years of the business. Great. So you do 20,000 plus 15,000 times 19. That'll be 820, right? Okay, there you go. So if you're doing this, wait, hold on. Wait, hold on. Do I have this correct? Yeah. So yes, that's correct. There you go, $3.25 million. Yep. Okay. We're good? Makes sense? Okay. So I do have more challenging problems on this stuff, but that's okay. You guys are just kind of scratching the surface here at the stuff. So let me tell you what the homework's going to look like. Guys, give me a moment. Let me figure out how I want to turn the homework.
That's why I went from I see you. Oh, guess what? J-Mac, that's the funny part. We did, so we got another picture. Well,
Hold on.
So then you just do 3 times 1.
Oh, one last thing, guys, I forgot to show you really quickly. I'm still recording. One last thing that will help you guys tremendously. In the calculator, I'm recording, which is good, so you guys can see it. You can actually do the sigma notation. So that little E looking thing that looks Greek. Did I? I did show you summation. Okay. Alpha window. Yeah, option 2. Yeah, like X. Yeah, I'm looking at the notes again. Yeah, 2 plus 3n. Use X. Yeah, there you go. Okay, so we're good.